Okay, so let's talk about LLMs again. Just now, 3 months ago, I found a good example that demonstrates pretty well how LLMs don't actually understand their inputs or their outputs. And here's the example. User input. List every word that contains the letter S in the sentence. It's not going to get this right every time. It answers, the words that contain the letters S in the sentence, it's not going to get this right every time, are 1, it's, 2, this, 3, right, 4, every, with a note of right is included since it has an S when considering the plural form rights. I'm going to ignore that it got some words wrong because there's always a very vocal crowd that screams, hey, it doesn't see words, it sees tokens. So of course it doesn't know which word has an S in it and which one doesn't. And yes, that's true. We'll get to what a token is later. But here's the thing. LLMs do have knowledge. They do know things about those tokens. But the same people also claim that LLMs would be great for letter-sensitive applications like programming. No contradictions here. Anyway, let's focus on the node and why that is completely wrong. But first, without diving deep into how LLMs do work and how artificial neural networks are nothing at all like biological ones, subject for a different video, let's quickly look at how they do work. An LLM takes in a stream of input tokens, which can be words or parts of words, and predicts the next statistically most likely token. Let's say the input stream is, I go outside because. Then the model might answer, sunny outside with a half probability, I'm hungry with 0.3, and I have no other choice with 0.2. The temperature setting controls which one it is likely to choose. Higher temperature lead to more random outputs, and lower temperatures tend towards the most probable. And if you, as an experiment, set it to 0, the models tend to get stuck in a loop. They'll pick the same tokens over and over and over again. Once the model makes this choice, the entire input and the new token is fed back into the model to generate another token. And this continues until a certain stop condition is met, be that the maximum number of output tokens or a special termination token, which just says, I'm done. This process describes how they work in general. It's crucial to emphasize that a LLM does not understand what those tokens mean. What it does is predict which tokens are statistically more likely to follow other tokens. At its core, an LLM is a statistical model of our language. It's very good at predicting patterns, but it doesn't understand our language in any meaningful way. Let's return to our example. It first produced this list, and then this list got fed back into it as an input. It saw that right does not contain an S, so it wanted to justify it. And it does this by taking the plural form. The only problem is that right, as in correctness, does not have a plural form, whereas right, as in your legal right, does have a plural form. And that is a completely different word. They just happen to have the same pattern. This highlights the key issue. They don't actually understand any of this. They are simply predicting patterns based on an enormous dataset of our language. Sure, they can sometimes produce text that sounds really intelligent, but that's all based on statistical pattern prediction and not comprehension. This is also why LLMs tend to generate incorrect or wrong summaries and explanations. They latch onto certain keywords or phrases and extrapolate based on patterns without really understanding how those fit together. Okay, so now just for fun, let's see what our very dear friend thinks about my script. Hey, ChatGPT, evaluate the correctness of a script. And then I also asked it to summarize, because I'm not reading all of that out. Sure, the script is clear, accurate, and engaging. It effectively explains how LLMs work, highlights key issues with a lack of understanding, and keeps things accessible without oversimplifying. So, there you have it. Even ChatGPT agrees that it is just a statistical parrot. Thank you for listening.